Steady state characteristics of a MOSFET. The MOSFET is a voltage control device having high input impedance. A gate draws a small leakage current in the order of nanoamps. The current gain ID to Ig is typically in the order of 10 to the power of 9 amps. However, the current gain is not an important parameter in this. The important parameter in this is a transconductance represented by a GM. Transconductance is the ratio of the output current ID to the gate voltage VGS. Defines a transfer characteristics. The deflection type MOSFET, a transfer characteristics. This is VGS, that is ID. After pinch of voltage, the current is going to rise. This is for N channel. For P channel, this is VGS, and this is our minus ID. After pinch of voltage, the current is going to decrease. Similarly, for enhancement type, transfer characteristics, VGS, ID. After VT, threshold voltage is the reference, increases. N channel, this is VGS, and this is minus ID, so VT decreases. This is for P channel, enhancement type MOSFET. These are the transfer characteristics. Output characteristics of enhancement type MOSFET. N channel. This is VGS1, so VGS2, and so on. GS4. This is the increasing order of the VGS. This line belongs to VGS equals to threshold voltage VT, and this is a linear region, and this is the saturation or pinch off. So for N channel enhancement type MOSFET, there are three operating regions. That is, first one is cutoff, where VGS is less than or equals to VT. That is nothing but this is equal, so below which it is cutoff region. Second one, pinch off or saturation, where VDS is greater than or equal to VGS minus VT. Third one is a linear region. Here VDS is less than VGS minus VT. Now if you observe in this linear region, ID is going to vary proportional to the VDS. As VDS increases, IG also increases. That is a drain source voltage and drain current. Here the current is very high, so due to high ID and low VDS, the power MOSFETs are operated in the linear region for switching actions. In saturation, if you observe, even the voltage VDS is going to increase, the current is going to remain for each VGS, that is gate source voltage, or else we can say in pinch off region, ID is almost constant. For voltage amplification purpose, we operate MOSFETs in saturation region. Transconductance GM is equals to change in output current divided by the change in input voltage, that is VGS, where VDS is constant. Output resistance R0 or DS given by a change in output, that is voltage VDS divided by the output current is delta ID. And this output resistance normally very high in pinch off region, typically mega ohms or not in saturation. In linear, high changes in currents and low changes of voltage, so R0 will be small in the order of milliohms. And this is the circuit diagram and equivalent circuit By seeing the structure, you can say dotted, you can say it is enhancement type, and the arrow is coming towards the gate, which means it's an N-channel MOSFET. This is a steady state model of N-channel enhancement type MOSFET. For deflection type MOSFET, the gate voltage could be either a positive or negative, but the enhancement type MOSFET responds to a positive gate voltage only. Power MOSFETs are enhancement type. Deflection type we use for logic designs.